Hello, space fans, and welcome to another edition of Space Fan News. This week, Hubble analyzes the first atmosphere of a super-Earth exoplanet, Lisa Pathfinder gets ready to take data, and the Chandra X-ray Observatory discovers a jet from a distant supermassive black hole being illuminated by the oldest light in the universe. For the first time, astronomers were able to analyze the atmosphere of an exoplanet in the class known as super-Earths. Using data gathered from the Hubble Space Telescope and using new analysis techniques, the planet 55 Cancri E was revealed to have a dry atmosphere without any indications of water vapor. These results suggest that the atmosphere consists mainly of hydrogen and helium. Now, a super-Earth is a special class of exoplanets that are rocky and similar to our Earth, only larger. They go from roughly 1 to 2 times the mass of Earth up to about 10 Earth masses. Super-Earths are substantially below the mass of the solar system's ice giants, Uranus and Neptune, which are 15 and 17 Earth masses respectively. Now, the term super-Earth refers only to the mass of the planet. It says nothing about the surface conditions or its habitability. So the exoplanet studied by Hubble, 55 Cancri E, is a super-Earth with a mass of 8 Earth masses. It is located in the planetary system of 55 Cancri, a star about 40 light-years from Earth. Using observations made with the Wide Field Camera 3, or also known as WFC 3, on board Hubble, the scientists were able to analyze the atmosphere of this exoplanet. This is important because this is the first detection of gases in the atmosphere of a super-Earth. This hasn't been done before on a planet this size. Although the WFC 3 instrument on Hubble has been used to probe the atmospheres of 2 other super-Earths in the past, no spectral features were found in those previous observations. 55 Cancri E is an unusual super-Earth because it orbits very close to its parent star. A year on this exoplanet lasts for only 18 hours, and temperatures on the surface are thought to reach around 2,000 degrees Celsius. Now, it turns out that being so close to its parent star was a good thing because this allowed the team to use a new analysis technique to extract information about the planet while it was transiting in front of the host star. So what they did was they made observations by scanning the WFC 3 very quickly across the star to create a number of spectra. Then they combined those spectra and processed them through software. And from that, the researchers were able to retrieve the spectrum of 55 Cancri E that was embedded in the light of the parent star. This technique allowed the team to examine the atmosphere in detail and revealed the presence of hydrogen and helium, like I said, but no water vapor, which, let's face it, astronomers get kind of fixated on because it may mean that the planet might be more habitable or there might be possibilities of life if they find some there. But I mean, come on, 2,000 degrees Celsius? Not going to be living there anytime soon, I think. So now we have one of the first insights into the atmosphere of a super-Earth. We have clues as to what the planet is currently like and how it might have formed and evolved, and this has important implications for 55 Cancri E and other super-Earths. Interestingly, another thing they found were hints of hydrogen cyanide, which is a marker for a carbon-rich atmosphere. Now, the team astronomers say that such an amount of hydrogen cyanide would indicate an atmosphere with a very high ratio of carbon to oxygen. And they also say if the presence of hydrogen cyanide and other molecules is confirmed in a few years by the next generation of infrared telescopes, it would support the theory that this planet is indeed carbon rich and a very exotic place. Now, one more thing. Hydrogen cyanide, also called prussic acid, is highly poisonous, so this place may not be high on our list of tourist attractions. Although maybe Baltimore. Nah, just kidding. Next, this is a follow-up from SFN 144. Lisa Pathfinder, a spacecraft designed to test the technology needed to detect and measure gravitational waves in space from a, hopefully, future large-scale space telescope like, I don't know, maybe LISA, the Large Interferometric Space Antenna, began its science mission this week by deploying its 2 test cubes inside the spacecraft. I can't tell you how many times I was saying test tubes. Now, for those of you who don't remember, Lisa Pathfinder has on board 2 identical 46mm gold platinum cubes that will be placed in the most perfect freefall conditions possible from its perch at the L1 point, which is a spot 1.5 million kilometers away from us towards the sun. So this week, for the first time, the two masses in the heart of the spacecraft are floating freely, several millimeters from the walls of their housings. The cubes sit only 38 centimeters apart, linked only by laser beams. So here's how it went this week. Each cube remained in the center of its housing, which was held by a pair of rods, softly pushing on two opposite sides. Then these rods were released from one test mass and then from the other one a day later, leaving the cubes floating freely several millimeters from the housing wall, with no mechanical contact with the spacecraft whatsoever. So now astronomers are really holding their breaths, telling everyone not to touch it, no touchy, because next week the fun begins. Sitting in its purest possible freefall, these cubes will be at complete mercy of gravity, with no other forces acting on them whatsoever. Right now, though, tiny electrostatic forces are being applied to move them around and make them follow the spacecraft, as its flight through space is slightly perturbed by outside forces such as pressure from sunlight. Now, next week on February 23rd, the team will switch LISA Pathfinder into science mode for the first time, and they'll turn off those tiny electrostatic bursts, and when it does, the cubes will be in complete free fall. After that, the spacecraft will start looking at those cubes really carefully and sensing any motions towards them owing to external forces. Microthrusters will make minuscule shifts in order to keep the craft centered on one mass. Microthrusters and minuscule in the same sentence? Not so great. Then the scientists will be in a position to run several months of experiments to determine how accurately the two freely flying test masses can be kept positioned relative to each other. And all the while, they're going to be making measurements with the lasers that link them. The idea is to see how accurately they can measure these movements, because that's the technique the real spacecraft, something like LISA, will use to detect gravitational waves, with the exception that the interferometer nodes will be tens of thousands of kilometers apart. For LISA Pathfinder, the required accuracy is on the order of a millionth of a millionth of a meter. Now, it should be noted that NASA and ESA decided in 2011 not to proceed with the LISA mission. LISA was not the highest ranked mission in the 2010 Decadal Survey. Now, it went to W first. And funding constraints prevented NASA from proceeding with multiple large missions, so they had to give it up. But given the latest news from LIGO, however, last week, I really hope that changes. Finally, astronomers have used NASA's Chandra X-ray Observatory to discover a jet from a very distant supermassive black hole that is being illuminated by the oldest light in the universe. This discovery shows that black holes with powerful jets may be more common than previously thought in the first few billion years after the Big Bang. The light detected from this jet was emitted when the universe was only 2.7 billion years old, a fifth of its present age. In this period of the universe, the intensity of the cosmic microwave background radiation, or CMB, left over from the Big Bang was much greater than it is today. The length of this jet, found in the system known as B30727 plus 409, is at least 300,000 light years long. Many long jets emitted by supermassive black holes have been detected in the nearby universe, but no one is exactly sure how these jets give off X-rays. In B30727 plus 409, it appears that the cosmic microwave background is somehow being boosted to X-ray wavelengths. Astronomers say that because we're seeing this jet when the universe was less than 3 billion years old, the jet is about 150 times brighter in X-rays than it would be in the nearby universe. As the electrons in the jet fly from the black hole at close to the speed of light, they move through the sea of CMB radiation and collide with microwave photons, boosting the energy of the photons up to the X-ray band, allowing it to be detected by Chandra. This implies that the electrons in the B30727 plus 409 jet must keep moving at nearly the speed of light for hundreds of thousands of light years. Electrons in black hole jets are usually quite bright at radio wavelengths, so typically these things are found using radio observations. The discovery of the jet here is special though, because so far almost no radio signal has been detected from this object, while it's easily seen in the X-ray image. Now, the team say they essentially stumbled onto this jet because it happened to be in Chandra's field of view while they were observing something else. Scientists so far have identified very few jets distant enough that their X-ray brightness is amplified by the CMB as clearly as in this system. But if bright X-ray jets can exist with very faint or undetected radio counterparts, It means that there could be many more of them out there because we really haven't been systematically looking for them in X-rays. Supermassive black hole activity, including the launching of jets, may be different in the early universe than what is seen later on. And astronomers say that by finding and studying more of these distant jets, we can start to grasp how the properties of supermassive black holes might change over billions of years. Well, that's it for this week, space fans. Thanks to all the Patreon supporters who are helping bring SFN to YouTube and make it better. And thanks to all of you for watching. And as always, keep looking up.